Intermediate Algebra for Statistics, Using Substitution to Solve Systems, Part 3, Lesson Objectives. Use substitution to solve systems of linear equations. Solve inconsistent and dependent systems by substitution. We'll begin with an example. Example 6. Solve the system 3x minus 6y equals 30, y equals negative 6x plus 34. So our first step is we want to identify an equation that has x or y by itself. So that's the second equation. So what I'm going to do is I'm going to take this expression, negative 6x plus 34, and substitute that into the first equation. So the first equation, 3x minus 6y equals 30, becomes 3x minus 6 times the expression negative 6x plus 34, and that is equal to 30. Using the distributive property, I'm going to take negative 6 times a negative 6x, that's a positive 36x, and then I'm going to take a negative 6 times a positive 34, and we get a negative 204. So our equation becomes 3x plus 36x minus 204 equals 30. Next step, we want to combine like terms here, and we have 39x minus 204 equals 30. Add 204 to both sides. We are left with 39x equals 234. Dividing by 39, we see that x is 6. So our next step is to take either original equation, and everywhere we see an x, substitute a 6. It's going to take the least amount of work if we use the second equation. So we have y equals negative 6x plus 34, or we have negative 6 times 6 plus 34. So now we have y equals negative 36 plus 34, which gives us a result of negative 2 for y. So the solution to this system is 6 comma negative 2. To verify this, using our first equation, we have 3 times 6 minus 6 times our y, which is negative 2. Hopefully that equals 30. So we have 18 plus 12, because a negative times a negative is a positive, and 18 plus 12 is 30. It checks. For the second equation, so we have negative 2 equals negative 6 times our x, which is 6, plus 34. Negative 6 times 6 is negative 36, plus 34 is negative 2. So we have left hand side equals the right hand side. We have verified the solution. Example 7. Solve the system 3x plus 5y equals 2 and x plus 4y equals negative 4. So for this example, we do not have an equation where x or y is isolated. I'm going to pick the second equation and solve for x because it has a coefficient of 1. This ensures me that I will not have fractions. So taking the second equation and solving for x, we have to subtract 4y to both sides. So we have x equals negative 4y minus 4. Now I'm going to take that expression and substitute that into the first equation. Wherever I see an x, I'm going to substitute negative 4y minus 4. So we have 3x plus 5y equals 2. Everywhere I see an x, I'm going to substitute the expression negative 4y minus 4. Now using the distributive property, we have negative 12y minus 12 plus 5y equals 2. Combining like terms, 5y and negative 12y gives us a negative 7y. Bring down your minus 12, bring down your equal sign, bring down your 2. Now we need to add 12 to both sides. We have negative 7y equals 14. Now divide by negative 7, and we see that y is equal to a negative 2. To find x, we take either equation. I'm going to use x minus negative 4y minus 4. Everywhere I see a y, I'm going to substitute negative 2. So this gives me x is equal to negative 4 times negative 2 minus 4. That becomes 8 minus 4. Therefore, we have a result of 4 for x. So the order pair, we always put x first, will be 4 comma negative 2. To verify this, we substitute the values in for x and y. So we have x equal to 4, y equals negative 2. This quantity on the left hand side should equal 2. 3 times 4 is 12. 5 times negative 2 is a negative 10. 12 plus negative 10 is positive 2. It checks for the first equation. For the second equation, we have 4 plus 4 times negative 2. That should equal negative 4. 4 plus negative 8. That should be equal to a negative 4. And when we add these two, we see the left-hand side equals the right-hand side. It checks. So we have verified the solution. Example 8. Negative 0.2x plus 0.2y equals 0.6. And we have 0.1y equals 0.5x minus 2.2. So here's our first example involving decimals. I'm going to take the second equation and I'm going to multiply everything by 10, so that way this coefficient becomes a 1. So if we multiply everything by 10, we see this becomes 1y. 10 times 0.5 is 5, and 10 times negative 2.2 becomes a negative 22. So now I'm going to take that expression and substitute it in the first equation for y. So we have negative 0.2x plus 0.2y equals 0.6. Making the substitution and using the distributive property, we now have negative 0.2x plus 1x minus 4.4, and that equals 0.6. Combining like terms, negative 0.2 plus a positive 1 makes a positive 0.8 times x minus 4.4 equals 0.6. Adding 4.4 to both sides, we have 0.8x equals 5. Dividing by 0.8, we see that x is 6.25. To find y, it would make sense to use this equation. Everywhere I see an x, stick 6.25. 5 times 6.25 becomes 31.25. Minus 22 gives us a value for y of 9.25. So the solution to this system is 6.25 comma 9.25. For this example, it would be very hard to get the exact answer using the graphing method. To verify that this is true, we take both equations, we substitute the values of x and y in, and we are left with 0.6 equals 0.6, so that checks. For the second equation, we substitute the values for x and y, and we work it out, and we see that it works for the second equation. So we have verified the solution. Example 9. Solve the system by substitution. Negative x plus 2y equals 8, and y equals 0.5x plus 4. Since the second equation is solved for y, we're going to take this expression, and everywhere we see a y, we're going to substitute it into the first equation. Using the distributive property, 2 times 0.5 is 1. So we have negative x plus 8. That equals 8. Combining like terms, these x's cancel, so we're left with 8 equals 8. That's a true statement. And when that happens, we know that the system is dependent. There's an infinite number of solutions because the two lines are the same line. Now, one way of writing a solution, and you'll see this in some algebra books, is they would write it x comma y, that means this is the solutions, such that, and then they give the equation. So these two equations will yield the same line, y equals 0.5x plus 4. So whatever works for 0.5x plus 4, whatever order pair is on this line, is a solution to this system. And there's an infinite number of solutions because there's an infinite number of points on the line. Our last example, example 10. Solve 2y minus 2x equals 12, 3y plus 9 equals 3x. So here's our first example where we do not have a coefficient of 1 in either equation. So for this example, it really doesn't matter if we solve for x or y here. Here, if we solve for x, we're going to divide everything by 3. And we're lucky we don't end up with any fractions. Or we could solve for y and divide by 2, or we could solve for x and divide by 2. I'm going to take the second equation and solve for x. So I'm going to divide by 3. This gives me y plus 3 equals x. And of course, that's the same thing as saying x equals y plus 3. So using the first equation, everywhere I see an x, I'm going to substitute y plus 3. So this gives me 2y minus 2 times the quantity x plus 3. That equals 12. Using the distributive property, negative 2 times y and negative 2 times 3, we have 2y minus 6 equals 12. Combining like terms, these cancel. We're left with negative 6 equals 12. That's a false statement, so we know that the lines are parallel. We say the system is inconsistent and there is not a solution. So let's summarize. Determine the number of solutions using the slope and the y-intercept. So we saw in the previous videos we can have one solution, we can have no solution, and we can have infinitely many solutions. And we can verify the number of solutions just by using the slope and the y-intercept. If the slope is different, we will have one solution and the y-intercept is not important. So whenever we have two equations that have different slopes, we will have one solution. There will be a point of intersection. When we have no solution, that means the slopes must be the same because they're parallel, and the y-intercepts must be different, because if the y-intercepts are not different, then they become the same line. For an infinite number of solutions, again, the slope is the same, but the y-intercept must be the same because the lines must coincide. They must be the same line. Thanks for watching.